Exponential and logarithmic functions can be used to model various situations. Sound levels are measured in decibels, or dB, which is a logarithmic scale. pH is a log scale used in chemistry, biology, physics, medicine, agriculture, and other sciences. The Richter scale, used to measure the magnitude of earthquakes, is a logarithmic scale. Some helpful formulas used to solve application problems are given below. The general growth model, A equals P times 1 plus R to the T power, where A is the final value at some time T, P is the initial value, R is the growth rate, and T is the number of years. And here we have the general decay model, A equals P times 1 minus R to the T power, where A is the final value at some time T, P is the initial value, R is the decay rate, and T is the number of years. For compound interest, we use this equation, A equals P times 1 plus R over N to the NT power, where A is the total account balance, P is the principal or starting balance, R is the annual interest rate, T is the number of years, and N is the number of times per year that the interest is compounded. Here we have the half-life formula. A of t equals A naught times 1/2 to the n power, where A of t is the amount left after n half-lives, A naught is the initial amount, and n is the number of half-lives. This can be written as A of t equals A naught times 2 to the negative n power, taking advantage of the fact that 1/2 equals 2 to the negative 1 power. A can be an amount of mass, m, or the number of nuclei, n. M of t equals m naught times 2 to the negative n power, or n of t equals n naught times 2 to the negative n power. From our previous formula, n was the number of half-lives which have elapsed. It can be calculated on its own using the formula n equals t over tau, where t is the time elapsed and tau is the half-life of the material. Combining our formulas yields A of t equals A naught times 2 to the negative t over tau power. Here's an example. A scientist is conducting an experiment on a 100-gram sample of a substance. The half-life, tau, for that substance is 75 days. How long will it take for the sample to reach 10 grams? All right, so A of t equals A naught times 2 to the negative t over tau power. So we plug in what we know. 10 equals 100 times 2 to the negative t over 75 power. So 10 grams is the amount we want to end up with. We start with 100 grams, and we plug in the half-life here, and we're going to be solving for t. So when we solve this, we get 0.1, because we divide both sides by 100. 0.1 equals 2 to the negative t over 75 power. Take the log of both sides, and we'll continue on the next slide. So we get negative 1 on the left, and negative t over 75 times log 2 on the right. Then we multiply both sides by 75, actually negative 75, so we cancel out those negative signs. And then we divide both sides by log 2. We put this in our calculator, and we get t is approximately equal to 249.14, which is how many days it will take for the sample to reach 10 grams. How long would it take for an investment of $10,000 to increase to a total of $25,000 compounded quarterly at a rate of 3.5%? All right, so we use our formula for compounded interest, and we have 25,000, which is our ending account balance. We have 10,000 as our principal. 1 plus 0.035, that's our rate, divided by 4, since we're compounding quarterly, which means 4 times a year, to the power of nt. So in this case, that's 4t, and we're solving for t. So we divide both sides by 10,000. We get 2.5 equals 1.00875 to the 4t power. Take the natural log of both sides. And then here we make that exponent into a coefficient. We're going to divide both sides by 4 times the natural log of 1.00875. So we're solving algebraically for t. Put this in your calculator, and we get an answer of about 26 years and 4 months.